Back to Educator.com. This next lesson, we're going to talk about triangles and some different ways we classify them. Okay, so a triangle is a three-sided polygon. Now, a polygon is any figure that has sides and it's closed. So, a polygon can look like that, okay, as long as it's closed and all the sides are straight. If I have that, it would not be considered a polygon. Okay, and if I have just maybe something like this, that's not a polygon either because it's not closed. So, example of polygon. So a triangle is a polygon with three sides. Now, a triangle is made up of sides, vertices, and angles. So the sides are these right here. So it'd be AB, side AB, side BC, and side CA or AC. Okay. The vertices are the points. Vertices. The word vertices is a plural of vertex. So if I just talk about one, then I would just say vertex. But since I have three, it's vertices. And that would just be point A, point B, and point C. Those are my vertices. The angles. Now, I can say angle, for this angle right here, let's say I can say angle ABC, or I can just say angle B, because I can, as long as there's only one angle, if I have a line that's coming out through here, then I'll have several different angles, so I can't label it angle B. But as long as there's only one single angle from that vertex, or the vertices, then you can label the angle by that point. So this angle right here can be called angle B. This angle can be called angle A, since there's no other angle there. This angle can be called angle C. So, or you can just, do it the other way, angle ABC, angle BCA, angle BAC. But this is the easiest way. Angle B, angle A, and angle C. Okay? So that's the triangle. Now to classify triangles, we can classify them in two ways, by its angles and by its sides. These are the ways we can classify the triangles by its angles, meaning based on the angles of the triangle, we have different names for them. So the first one, acute triangle. Acute triangle, well, we know acute angle is an angle that measures less than 90, right? Smaller than 90. So an acute triangle is a triangle where all the angles are acute. Okay, all the angles measure less than 90. Okay, the next one, obtuse triangle. One angle is obtuse. Now, all triangles have at least two acute angles. So the way we classify these other ones, like for this one, an obtuse angle is an angle that measures greater than 90, right? Only one of them will be obtuse. There's no way you can have a triangle with two obtuse angles. So that means two of the angles, since we have three, two of the angles is going to be acute, and then one of them is going to be obtuse. Okay, but all triangles must have at least two acute angles. So here's an obtuse triangle. So here's your obtuse angle and then your acute angles. Same thing for the next one, right triangle. A right triangle is when only one angle is a right angle. So like this, right? Right angle. again, the other two angles must be acute. Now, if I try to draw two angles of a triangle to be right, see how there's no way that could be a triangle, okay? So, because a triangle, remember, it has to have three sides. Tri and triangle, this right here, tri, means three, okay? Okay. Now, equiangular triangle means that all the angles are equal. Equal angle. Can you kind of see the two words formed in there? So equiangular, when all the angles are congruent. Now, if all the angles are congruent, then each angle is going to measure 60 degrees. Now, we're going to go over this later on, but the three angles of a triangle have to add up to 180. Okay? So if all three angles are congruent, then I just do 180 divided by 3, because each angle has to have the same number of angles, or measure degrees. So 180 divided by 3 is going to be 60. So this will be 60, 60, and then 60, okay? And that is an equiangular triangle. And of course, an equiangular triangle is an acute triangle because 60 degrees is an acute angle. All three angles are acute, right? Okay, so equiangular triangle, all angles are congruent. They all measure 60 degrees. Okay, so then classifying triangles by sides. So we just went over by angles, depending on how the angles look, if it's a right angle in the triangle, an obtuse angle, or an acute angle. Okay, we can also classify triangles by the sides. So if I have a triangle where no two sides are congruent, all three sides are different lengths, like this is 3, 4, 5, then this is a scalene triangle. So I can show this by making little slash marks. I can make this once, then this I'll do twice to show that these are not congruent, and then I'll do this one 3 times. Okay, so that shows that none of these sides are congruent to each other. And that is a scalene triangle, scalene. The next one, isosceles triangle, is when I have at least 2 sides being congruent. Okay, so at least 2 of the sides. And then equilateral triangle is when all the sides are congruent. So an equilateral triangle will be considered an isosceles triangle because isosceles, anytime you have at least, meaning 2 or 3 sides being congruent, then it's considered isosceles. But this is a more specific name if all 3 are congruent. Okay, so you would call this an equilateral triangle, but it's also considered an isosceles triangle. Now, remember this one, equilateral? So equiangular is when all the angles are congruent, and equilateral is when all the sides are congruent. Okay, so these are some ways you classify triangles by the sides. Isosceles triangle. Okay, so I see here that these 2 sides are congruent, which is an isosceles triangle. If I label this as triangle ABC, then I can say triangle ABC, okay, is isosceles. So anytime you have a triangle, you can label it like this. Okay, triangle ABC. Just like when you have an angle, you can say angle A. So if you have a triangle, you're going to say triangle ABC. Okay. So this right here, this side that's not congruent to the other 2 sides is called your base. Okay? These 2 sides that are congruent are called your legs. Now the two angles that are formed from the legs to the base are called base angles. So base angles would be this angle right here and this angle right here. And then this angle right here, or that point, is called your vertex. Okay, this right here that's formed from the two legs, the two congruent legs, is called your vertex. Okay, so we have legs, we have vertex, we have base, and then you have base angles. Okay, and this makes up your isosceles triangle. And then just to go over the right triangle, these are also called your legs. But this one, it's not called base, it's called the hypotenuse, right? The hypotenuse. So just to review over that. Okay, so the isosceles triangle, these two are congruent, so they are called your legs. This one is your base. Now base, don't think that the base is the one always, the side always on the bottom. No, it depends on the triangle. I can move this triangle around and make it look like this. And I can say that these two sides are congruent, right? Then this would be my base, and these are my legs. Okay? So, find x, AB, BC, and AC. Let me just write this to show that they're my segments. So to solve this, if I want to solve for x, I know that these two are congruent, right? So since they're congruent, I can just make these equal to each other. 2x plus 3 equals 3x minus 2. Okay, then if I subtract the 3x, I get negative x equals, I subtract 3 over, so I get negative 5. X is 5. There's my x. AB is, and I'm not going to put a line over this one because I'm finding the length. If I'm finding measure, then I don't put the line over it. So AB is 2 times 5 plus 3. So that's 10 plus 3 is 13. Okay. And then for BC, since I know x, even though this side is the base and it doesn't have anything to do with these sides, okay, since I know x, I can solve for BC. That's 5 plus 1, okay, so BC equals 6. And then AC, 3 times 5 minus 2, so that's 15 minus 2 is 13. And that's everything. Okay, so again, if you have an isosceles triangle, they want you to solve for x, then you can just say that this, since these two sides are congruent, you can make these two congruent.